Hello friends, welcome to Chemistry Simplified. In this video, we're going to see about how to draw a molecular orbital diagram, how to calculate the bond order and predict the magnetic property of the molecule. So let's get started with the postulates of the molecular orbital theory. The electrons in the molecule are present in the newly formed molecular orbital, and these orbitals are obtained by the linear combination of atomic orbitals. Conditions for the atomic orbitals to overlap or to combine to form a molecular orbital are like they should possess same symmetry, similar energy, and must have spatial overlap. And number of molecular orbital formed is equal to the number of atomic orbitals involving in the formation. And filling up of electrons in the molecular orbital obeys the same principle whatever we adapted to write the electronic configuration of an atom. So let us see how to draw the molecular orbital diagram with a simple example of hydrogen molecule. So I'll just explain you how to draw it. Step 1 is that I just want you to mark the energy axis first, then hydrogen. So we know that there is only one orbital in hydrogen. It is 1s, and each of them has one electron. So now we are going to construct the molecular orbital diagram. So we are writing that in the center. See, now to this time, like there are two atomic orbitals are going to overlap to form the molecular orbital. So we get two molecular orbitals, namely one with a lower energy, we call that as a bonding molecular orbital, and one at the higher energy we call them as anti-bonding molecular orbital. We represent them like sigma 1s and sigma star 1s. So star represents the anti-bonding molecular orbital. Now totally there are two electrons in the hydrogen molecule. So we are going to fill up the electrons, and we're going to start from the lower energy level and go to the higher energy level. So let's see, 1 and 2. We have filled up the electrons and we have constructed the molecular orbital diagram for hydrogen. So how to calculate the bond order? I have given you the formula for the bond order here. So your bond order BO is given by the number of electrons in the bonding energy level. In this case it is 2, minus the number of electrons in the anti-bonding level. It is actually 0 in this case, divided by 2. So we get 1. So it is evident that there is a single bond between hydrogen and hydrogen in case of hydrogen molecule. And the next one is the magnetic nature. You don't see any unpaired in this case, unpaired electron in this case. So it is actually diamagnetic in nature. So let us extend this to a bigger molecule. So we'll try to extend to a higher atomic number molecules. So when you just go for higher members, there are two types. We have one set having atomic number less than or equal to 14, follow this kind of a molecular orbital arrangement, and atomic or numbers greater than 14, they just go for this kind of a arrangement. For example, like you can take nitrogen. So nitrogen, we know that 7 is the atomic number of nitrogen, so 7 plus 7 is 14, so it goes to this category. Whereas oxygen, O2, 8 plus 8, 16 belongs to this category. If you notice, the difference is that you could see the orbital overlap here, sigma p to z, sigma 2p is z, having higher energy level here, whereas here it's a lower energy level. So step 1 is that you have to calculate the sum of the total atomic number of the elements involved. So then we'll go for drawing the molecular orbital diagram based on the which set it belongs to. Step 1, again we already marked the energy axis. Then we're going to put the elements at the top, nitrogen and nitrogen. and we know the electronic configuration of nitrogen is 1s2, 2s2, 2p3. So in this case we have missed out sigma 1s and sigma 1s star. I hope it is understood by you the reason why it is. So we are just marking the other atomic orbitals. We have just marked them. So now we're going to construct the molecular orbital diagram. So we're going to fill up the electrons in the atomic orbital first. So now here we have 4 electrons. We're going to fill them up. 1, 2. So it is filled. So we go to the higher energy level. Likewise, we're going to fill up the 6 electrons in this case. So 1, 2, 3, 4, 5 and 6. So now we have just filled up the electrons and the molecular orbital diagram is done. So now we are going to calculate the bond order. So we know the formula bond order is given by number of bonding electrons. In this case it is 8 minus 2 divided by 2. So that equals 3. So it shows that between N and N in nitrogen molecule it is a triple bond, and it is also diamagnetic in nature. I hope you can cite the reason, because there is no unpaired electrons. Likewise, we can construct a similar molecular orbital diagram in case for oxygen. So we get started. So we are just marking the electronic configuration of oxygen is 1s2, 2s2, 2p4. So this should be 2s, 2s and 2p and 2p. So fill up the electrons in the atomic energy level first. So we are just filling it up. So now once we are done with that, we are going to construct the molecular orbital diagram for oxygen. So we are going to fill up the electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we have filled up, and the molecular orbital diagram for oxygen is done. So now I'm going to calculate the bond order. So bond order is going to be, so it's going to be like 8 minus 4 divided by 2, and it's going to be 2. So that implies that there is a double bond between the oxygen and oxygen in case of oxygen molecule. Come on, figure out whether it is diamagnetic or paramagnetic. Good, it is paramagnetic. I hope you can cite the reason with ease. So you can see that there is unpaired electrons in the molecular orbital. Here I will show you a simple question from the recent CSIR examination. I hope everybody aspires to clear the CSIR examinations. So this would be a really easier one. This is a question I have taken from the last CSIR examination, and I have just tried to draw down form of table. Rather, you can use simply remember this, so you can directly answer without fail. So this should be easy for us. This is a question. Now I am going to show you how to solve it without any problem. So we know that. So step 1 is that we are going to calculate the sum of the atomic numbers. So in this case it is 15. So it is a cation. So we are removing one electron. So that becomes 14. So now we are matching with the number 14. You could see that the bond order is 3. Likewise, in case of oxygen, it is 16 minus 1, that is 15. So again we are going to match it with this one. So the bond order is 2.5. Next one, it is 14 minus 1, that is 13. So we can match it here. And this is 12 minus 1, that is 11. So that's going to be here. So it is easy for us to calculate the bond order without drawing the molecular orbital diagram. So step is, you just have to find out the sum of the atomic numbers, add or minus based on the charge over the ion. Just you can easily find it. While finding out the magnetic property, there are two very rare cases where you might encounter a change, but the rest of the cases it holds good for most of the things we generally deal with. I think you can follow this table, it will be easy for you. I hope you have figured out the answer. So the right answer is this. Easy for us. Anyhow, thank you for watching. Have a great day.